Hi everyone, and welcome to today's flipped instructional recording on 1.13 engineering. So be sure to take notes during this recording. We will hit some hotspots that you might see again on your unit test. You also want to title your note page with the lesson number and title. So as we get started today, we're seeing how engineering ties into physical science. So we want to draw conclusions based on the results of an investigation, and we want to extend and deepen our understanding of by discussing the content with our peers. However, in middle school, you will see discussion instructions at the end of the lesson, and there is not a discussion submitted for this lesson. So these are some things you can think about and write in your student guide just to help make sure that you are understanding the content. And so question 1 says, what are some design constraints engineers must consider? And 2, how do engineers start the process of creating a design? So we know that engineers find solutions to problems. So in this lesson, we will design a solution to a problem. And then there is a discussion again, but you will not be submitting that part. All right, so as we talk about finding solutions, the problem could range from developing the best packaging for a fragile object to designing a parachute for a part of a rocket. Here's a problem that you're going to try to solve. A door is missing a bumper and has caused a dent in the wall. What are some questions you might ask before considering a solution to the problem? What materials can be used to create a bumper? How much can the bumper cost? And how big does the bumper need to be? So if we're looking at this, we are trying to figure out how to keep this from making a bigger hole in the wall. And engineers design solutions to problems. They must consider the constraints of the design, including cost of the materials, time to develop the solution, and the environmental impact. Research. So engineers often start by conducting research about the current available technology. Take a look at some door bumpers. So here are some possible solutions. How are they similar? They all look like they're made out of elastic materials. So you can see there is some type of rubber cushion. And how are they different? So we can see that one's mounted on the ground, one's mounted high on the wall, and one is mounted low on the wall. Engineers construct models to compare different solutions. The models must be evaluated against the constraints of the problem to determine which solution is best. Consider this student's idea. To protect the wall from the doorknob could be wrapped in bubble wrap. What are some potential problems with this design? Problem 1, the bubbles in the bubble wrap could pop and eventually wouldn't work. Problem 2, the bubble wrap would make it harder to open the door. Problem 3, it wouldn't be environmentally friendly to replace the bubble wrap each time that it's used up. So test and revise. Engineers build prototypes, preliminary models, and test them. They compare the effectiveness of the models and revise them as they gather information about which models worked well and which ones did not. Design a solution. Consider what you've learned about elastic objects in this unit and apply it by designing a door bumper to protect a wall from being damaged by a doorknob. The door bumper should be bouncy enough that the wall is not damaged, but not too bouncy so that the door bounces back. The specific constraints of your design are outlined here. The bumper must be 1, attached to either the door, wall, or floor, and 2, made with household items. After you design your bumper, you will discuss with your classmates about how you designed your door bumper and compare your design to others. All right, so these slides moving on are not required because you're not submitting a discussion. So you do not need the rubric and you do not need the discussion prompt. So once you have read through all of the slides in the lesson, you are finished.